Hi everyone. So I've met you all now. Louise, Hannon. I'm with NUIG Galway. I'm based in the Department of Civil Engineering, and I'm working with Clifford, who was here earlier, who got called away, and Sean Mulligan. And we've been working on the pilot sites primarily, but also feeding into all the other work packages. But the pilot sites are there's a work package that we manage, and in particular the two pilot sites in Galway, which is Waternomics Secondary School and this building here. So I just wanted to talk to you a little bit about the pilot sites, our objectives, the measures we implemented, and the outcomes that we have so far. So the layout of the presentation, we'll keep it simple. I'm going to give you a brief profile of the pilot sites, and considering that we've just toured one of the pilot sites, you may know a lot more than you did 20 minutes ago. The second part, I'm going to look at the stakeholders and the objectives. Then I want to talk about the interventions and the measures implemented here, and the results from the pilots. I'm going to present briefly some results from the pilots. These are mainly to do with the pilots here in Galway, Waternomics and NUIG Galway. And I can tie this quite well actually into Xandra's presentation earlier talked about the Waternomics methodology. The Waternomics methodology gave us a toolkit with which to implement a water management program in a building should you want to. It was assess, plan, do, check, act. Now, as part of the pilot planning process, this is the methodology that we followed. So we trialed the Waternomics methodology in our 4 pilot sites. So what was the role of the pilot sites? We've told you that we have 4 pilot sites here. What was the role? You're familiar at this stage with the overall objective of the Waternomics project, which is to use ICT in a water management plan framework as an enabling technology to achieve our goals: managing water resource, increase end user conservation awareness, affect behavioural changes, and avoid waste through the leak and flow protection. And these are our overarching objectives. And the role of the pilot sites in this. Well, the pilot sites were chosen to pilot, demonstrate, and validate the innovations of the Waternomics project, which is what I've just discussed as we did with the Waternomics methodology to begin. Also to engage with the pilot site stakeholders, okay? And then to analyse the efficacy of the systems. How effective are these systems that we've put in place? So our 4 pilot sites, I think you've probably seen this slide twice at least today. Our 4 pilot sites look at the corporate environment, the domestic environment, corporate environment with Linate Airports, privately owned business. The domestic environment, this is 6 houses in Greece, in a town in Greece, and then the public or mixed use environments, which is well represented by this building here in Waternomics, where we get access to the students and to the teachers, to the maintenance staff, to building managers. We met A earlier there today, who's been great throughout this whole project. So, having chosen our pilot sites, well, I just want to identify briefly our stakeholders. And the stakeholders in the different buildings, I mean, Waternomics, Linate, Kerning, they're all slightly different. So when the stakeholders are different and have different aims, the person who pays the bill is different to the person who just comes and goes, who doesn't really have a vested interest. The airport staff might be different to the airport passenger moving through the building. The child is different to the person who pays the bill in the house. But as Christos mentioned earlier, it was difficult to kind of to differentiate between different users in a household. So we identified our stakeholders, and then we talked to the stakeholders. In our initial work packages, work package 1s, we were really looking to identify if there were a water management program, water management plan in your pilot site, in your building, what are you interested in? What do you want? What do you want it to give you? So we were able to identify by interviews really what the stakeholders wanted, and to be able to come up with this. So these are just some small quotes from these extensive questionnaires and from these extensive interviews that we did in each of the pilot sites. We were able to map those to a set of, say, overall 5 common aims, 5 common pilot site objectives that really were common to all of our pilot sites and also fulfill the objectives of the Waternomics project. So this was, we want to increase awareness, we want to promote education, we want to reduce consumption, we want to improve operation, and we want to promote environmental responsibility. So these are pilot site objectives that we came up with that matched both the requirements of our stakeholders and also the Waternomics objective, the overarching Waternomics methodology. Then we set about matching, this slide just shows how we can match how different students are involved in different pilot site objectives. So you can see the staff are interested in promoting education and increasing awareness, and the bill payers, the managers, they want to reduce consumption because it reduces the bills. They want to improve the operation because, again, this reduces the bills. You've got a critical fault, much more difficult to fix than if you get early notification of a fault, and so on. So by identifying these pilot site objectives, our next step was then to identify measures by which we could achieve our objectives. So Owen went through earlier, very briefly, some of the measures that we implemented here to try and meet these objectives. So, in increasing awareness, the Waternomics platform applications, the public dashboard that we showed you downstairs, this is one of the biggest tools in this building, and there's a twin of that but designed specifically to be aimed at secondary school kids that's out in our other pilot site. This was a big way in which we were trying to increase awareness of water consumption. Also the interactive signage that I showed you downstairs with the QR codes, the public displays, these are all ways that we identified that we could try and increase awareness of water consumption within our pilot sites. Promoting education, workshops, water awareness workshops we did with kids, where we brought them in and we showed them, we made them get hand pumps and we showed them how we made them take water from one area, which was supposed to be, say, the river, and brought it through the treatment processes, physically brought it through the treatment process, so that they could better understand what was necessary for the water to come into their tap, to make that link, to understand that problem statement. And the problem statement was something that I spoke to you earlier when we were downstairs. It's a key issue. Once you show people the big number and they say, okay, yeah, that's our usage, like, what's the problem? Why should I adjust my ways? You need to tell them what the problem is. It's advertising psychology almost. You've got to show them what the problem is. So in terms of reducing consumption, so if you can increase awareness of how much you're using, then hopefully you should be able to influence people to change their ways. And improve operation. Improve operation was identifying network faults and diagnosing faults. And for the final objective here with promoting environmental responsibility was very specific to Lenate. In Lenate, corporate social responsibility was a big factor for them. As well as trying to make gains and secure their water infrastructure. So how did we go about assessing how we're successful or not? Well, an increase in awareness, we have our biggest factor there was awareness surveys. In promoting education, we can ask ourselves how many new projects have we got. In reducing consumption, we know the figures and we can show the figures to see. Improving operation, did we manage to find faults and identify faults that we wouldn't have otherwise found? In terms of promoting environmental responsibility, is that working in SEA? Are they adopting this? So these are our ways of assessing how successful we've been. So in terms of the awareness was measured by by an awareness survey, pre and post intervention awareness survey. So before any of those measures were implemented, the public dashboards, the display screens, the workshops, we took a measure to see what sort of awareness and how pro-environmentally inclined our student body was. And it's based on this thing called the norm activation model, which looks at different factors. Problem awareness, are you aware at all that the environment should be looked after? Ascription of responsibility, do you think it's got anything to do with you? Outcome efficacy, even if I make changes, are they really going to make a big difference? So this is what our pre-intervention surveys looked at. They were measured on a 5-point scale, and we also asked other questions. So these are some of the examples of the questions that relate to, say, the problem awareness, the outcome efficacy, the ascription of responsibility. So these are filled out with, I think, about 300-400 surveys, pre and post interventions in our different pilot sites, and these are some of the results. Now, in civil engineering, our first year engineers were surveyed in February 2016, that cohort. That was before any interventions were put in place. 1 year later, they were assessed, they were asked, the next class who came into first year engineering were asked the same set of questions. Basically, we saw very little difference in our over the year between the two different cohorts. We saw very little difference, very little, very small differences that really are not statistically significant. More interestingly for me, actually, is that the questions exactly, the answers exactly mirror each other from 1 year to the next. Also, what's very interesting about this is that the scale of all of these questions is from 0 to 5. And our baselines are very, very high, consistently high. 3.2, 3.3 is where we begin. So to try and achieve gains above this in a building in which you are not paying the bills for is, to my mind, quite difficult. So this may be a factor for us. We also had a control group who was in a building, same age group, in a building at a different end of the campus, and we got very similar results from this here. So, so this was our first finding. Colusha we did better, particularly in the junior cycle students. We measured the same groups 1 year between each other, and we did find increases from pre-intervention to post-intervention. With our 11 to 13-year-olds up to our 14 to 16-year-olds, these two different groups, all we saw a rise in their awareness, or in their problem awareness, how they were aware that there was a problem with water, and all the other measures. The senior cycle students, you can see they're not statistically significant. The differences that we have then, we have some rises and some falls, but the figures are very, very close. So again, we're getting to the point where it's very difficult to influence. Again, their baseline was higher, and it was very difficult to find any great gains in this. So, promoting education in terms of results. We had significant success in this, in that we had workshops that we ran that were attended by probably 150 students over during 2016. We have a couple of final year electronic engineering projects underway in the area of metering here, and in Colusha we had some student interns here. So we had focus groups and open days in Permi. We have involvement now with the secondary school hydro energy project underway at a local secondary school because of these workshops that we ran. And in 2017 we're hoping to, we touched just briefly on the tour there, the problem of exceeding retention times of water within a network. So this is one of the aims in the next 2 months, is to build a model of a potable water network within our labs, and to get that experiment underway. We've got 2 interns identified. We're going to be here for 3 months who carry out that water quality testing. So in terms of promoting education, I think we've been very successful. In terms of reducing consumption, was another aim of our of the project. We have showing you there the water system, the schematic in NUIG Galway. Our mains water, our cold water, domestic hot water, rainwater. Overall, what we have been able to do is we've been able to identify what our average usage is over the weekdays. Friday is a kind of an anomaly, people are going home, what have you, and our weekends. From this, once we were able to identify this, this was our baseline, and then we can see whether we're making any changes. Now, this is just showing a diurnal flow signature of a weekday, just to show where our peak time is. This speaks to flow signature, which we were also discussed earlier, so that we can, similar to what was presented by IHE, where they had an acoustic flow signature, and we have a volumetric flow signature. So we can, by being able to baseline our flow, we can identify problems. So we know what our biggest consumers of water are in the engineering building. Is 98% of it goes to the cold water supply, which is the meter that we're now have the acoustic meter on. So very little of it actually goes towards drinking water, which is a very big finding. Really, when all the water that's supplied to this building is fit for drinking, with the exception of the rainwater harvesting system, which I'll just go on to now in a minute. The most of the water, which is a huge volume of water every day supplied to this building, is not used for drinking purposes, although it is good enough to drink. So, of our cold water supply, we're finding that 60-75% of this actually supplies our rainwater tanks. And this is because we have identified in this project an ongoing problem with our rainwater harvesting system. So this has been an issue for us, and you can see when we looked at our pre and post intervention water usage data that we didn't achieve a reduction in consumption because of the difficulty we have with the rainwater harvesting system, which is possibly a gain in another way, in that we've identified a problem that exists that would be impossible to identify otherwise. So the rule-based FDD concluded that the rainwater harvesting system was at fault, and this is where a lot of our flow, our cold water supply is going, and this was confirmed by flow signature. So you can see there what happens in the building is in the rainwater harvesting system, this collects rainwater from the hard areas and surfaces and roofs, and all of that water should be used to flush the toilets and to flush the urinals. When there is no water, then it's topped up by our cold water supply, which is the same supply that comes from to the drinking water fountains. It's just stored, so it's good enough. It has been good enough to drink. When our rainwater harvesting system is not working, the tanks are topped up by cold water, and this is the flow signature. You can see here that it's constantly topped up on an hourly basis. We're getting top-ups into our rainwater harvesting system, and here you can clearly see how we identified that it was this fault. As you can't clearly see very much there, the blue and the red are 2 different tanks that we have in the attic, and they're being topped up by the cold water system, and there's water coming from the 2 tanks that are being topped up by the cold water system, and the black line is actually the cold water that's being supplied up to them. So the blue and the red equal the black, which tells us where the water is being used. So in terms of improving operation, we've also created at the improving operation, we've got a fault system now, which we touched on earlier there, to A, giving him alerts every day when potable water exceeds an allowable residence time. So that's in place and it works, and he gets alerts when he needs to do something. So I think that's a really good gain for us. I say that. So again, the baseline water consumption in Colossian and Curva pilot, we were able to determine what the water consumption is out there. We're looking at so in Colossian and Curva, they use about 4.5 cubic meters per day usually. Most of that is rainwater, and this is the way, if our rainwater harvesting system was working properly, this is the kind of saving that we would have instead of buying water from the local authority. That's the kind of system that we would be having. So they make huge savings. It's like nearly 70% of the water they use out there, of their 4 cubic meters per day, is actually harvested rainwater. So in Colossian and Curva, we've identified over the period of this project, we've identified 3 significant faults out there. And just to give you, this is one of the faults that we identified, and this is something that we touched on earlier. When you see a flow signature for a week or a day or a month or a year, you know roughly what the pattern should be. You know that there should not be a continuous flow such as what's identified here in red. You know that you have a problem. This problem was traced back again to a problem with the rainwater harvesting system out in Colossian and Curva, where it appeared to be like a faulty cistern or something. So it was just draining the rainwater harvesting tanks that unfortunately for them actually coincided with a very dry period, so that water was being topped up by the mains water supply. So there was a cost involved. It wasn't free rainwater, it was a fault that occurred at the same time. So dry period, and it resulted in 240 cubic meters of water being used for no reason. And that fault would not have been identified only for the monitoring that we were doing. The school get bills on a quarterly basis. So in terms of conclusions, in Lenate, I think, I've put up some of the conclusions there. I think the biggest conclusion in Lenate is that SEA are interested in extending this system to Malpensa Airport, and that speaks volumes. In Thermi, the people are interested, they have been engaging with the system. They are now more conscious of what they are using, and they will be able to tell you how much in terms of volume that they are using in their homes. In Galway, we create significant discussion because of our displays downstairs. People are much more, anecdotally, people are much more conscious of the number that they're using, of how much water is using. They understand the volume that's being used in the building. I think an important point for this building, because it's a municipal building, is that we have to consider water as operational or system controlled usage and user controlled, because it's quite difficult. You can see a fault that exists in our rainwater harvesting system. Now, there's always a problem in a municipal building in terms of stretched maintenance resources. So our problem, because there's not water running out of the doors, this problem is not getting fixed. It's a hidden fault, it has been identified, difficult to allocate resources to get that fixed. So the buy-in has to be from the management, from the operational side, to get that sort of thing fixed. There's only so much you can do from a user perspective, say the students in the building, although they make up most of the occupants of the building, they control very little in terms of the water usage here. So I think that's it. There's just some final remarks there, but I think I've really gone through all of them. So that's it.